Okay, the recording has started. So today I initially thought of going over the loops and recursion section, but I thought the list module is something that is relevant for that. So today we'll go through the list module, some of the basic functions that are available. Feel free to type in the chat if you have any questions. Feel free to post it on the chat, and we will proceed in going through the list section in the ocaml.org docs site. So we have seen some of these examples earlier. So let me clear this output in the ocaml.org site. So we know what is an integer list, right? This is an integer list, and a list, if it is not empty, it can have a head, which is the first element, and then it can have a tail, which is the rest of the elements in the list. And let's look at some more examples of lists. So we have an empty list, and then we can have a list of Boolean values. Some of it is repetitive from the previous sessions, but it's good revision here. And we can also have a nested list, right? So it's a list of integer lists, three, 4, and 5, 6. Let's clear the output and let's run this. And so we have a list of integer lists. Okay, that's how we read this. Note that the type of empty list is a list. The list element type is not known. There are two operators which you can use to add element to the front of the list. So the colon operator, for example, say 1 double colon is used to prepend to this list. So if you run this, we get the integer list 1, 2, 3. We can also use the append operator. And we should get the same integer list 1, 2, 3. Of course, we can write functions which operate on list. So remember that the elements of a list must be of the same type. Okay, that's the most important thing here. So let's write a simple total function which basically computes the sum of an integer list. So let's say let the recursive function total pass L, and of course we like to use pattern matching, and if it's the empty list we just return 0, and if there are elements in the list we use head and tail, and we use head plus we again call the total function with the tail of the list. Let's run this. The definition is fine, and now if I call total to a list, say 1, 3, 5, 3, 1, I run it, I get the sum 13. Okay. We can write a similar function, recursive function, to find the length of a list. So let's write length L. Again we do pattern matching, L with, if it's an empty list we return 0 because there are no elements to that. And in this case I don't care about the head of the list, I just treat it as one element. So 1 plus I recursively call the same length function with the tail of the list. Okay. We run this, the definition is good. So now I can do length of say an integer list, or I can call the length with a string list. Right. And I get the same result 3. So the length, in a way, this is a polymorphic function because you can operate the same function across different types of list. And I also do length of a nested empty list, just 1. Okay. Next we have an example of a append function using the append keyword. So let's try that. Append AB, and I match A with an empty list, just return B, or if there is a head and a tail, I create the new list with the cons operator and call append again the tail and B. So the definition is fine. Okay. So that's the version with the add operator for append. Now of course we can have higher order functions on list. So an example here is map. So if we have a new definition, a recursive definition for map, which takes f and an L, a function and a list, we do the pattern matching on the list. It's a empty list, we just return the empty list. It's a head and a tail. We call the function on the head, then we construct this new list, and we again call map with the function and the tail of the list. Okay. So we run this, and that's the definition. And then we can actually use this in an example. So we have a function which takes an argument and it multiplies the argument by 2, and we run this function on this list 1, 2, 3, and we should get the result 2, 4, 6. We can also invoke the total function, say on this list of list 1, 2, 3, 4, 5, 6. Right. And we get the total of each of those nested lists, so it will be 3, 7, and 11. Right. Good. Now, the standard library list has got a lot of useful utility functions, so you can definitely use them. And so where do you find this documentation? So if we go to OCaml.org docs web page, right, so we have this standard library API link here, and then for different modules, so if I click on list here, it opens the description for the module list and all the functions, some explanation here, right. This is useful and handy if you want to quickly refer to a specific type definition or usage and so on. Right, so let's go back and try writing function examples using the functions available in the list module. So we do have maps and iterators. So we've already written a map function from scratch. So in this example, we will try to use the built-in map2 function. So let me clear this output here. So the map2 functions and all the two functions apply to a pair of lists, right? So here, if we want to add two lists together, 1, 2, 3, and 4, 5, 6, right? So we expect the result to be the sum of 1 and 4, the first two elements, and then 2 and 5 and so on, right? So it's the result map2 applies the plus to the corresponding elements of the pair of lists, right? Of course, we can also do iter. So let's first check the, let me also give you the definition here. Print that out, right? So map2 takes a function and takes a list and a b list and returns a c list. What this function does, it takes a, b types and then returns a c type. Okay. So it's always good to see and know the type definitions before you use it. So similarly, let's do list.iter. What does iter do? It takes a function and a list and returns unit. So what this function does is it takes type A and returns a unit. Okay. So let's use this list.iter and definitely print inline returns a unit. And so we have a list of strings here, and if I run this, I get the output of Frank, James, and Mary, and returns a unit. Now, similar to the map2, we also have a iter2 definition. So what does iter2 definition look like? It takes a function and a list and a b list and returns a unit. What does the function do? It takes type A, type B, and returns a unit. Okay. So let's see an example here. We have list.iter2. It takes a function, takes type A, B, and need a function that returns unit. So this basically just concatenates A and B, and we have two lists. So we have Frank, James, and Mary, and then we have Carter, Lee, and Jones. Okay, let's run this, and of course we get Frank, Carter, James, Lee, and Mary Jones. So the corresponding elements of the list are applied to the function, and unit is returned. Now remember that both map2 and iter2, they will fail if the lists are of unequal length. For example, if I do something like list.map2, we do the plus, say the first list has got 3 elements, but the second list has got only 2 elements, right? So this will throw an exception saying invalid argument. list map to, right? Okay. Moving along, let's look at list scanning. So the mem function, let's see what its type definition is. Okay, it takes a type A and it takes a list of type A and returns a bool. Basically, it says whether the A type is present in a list, okay, and returns true or false. So let's try this example here. List dot mem. If Frank is a member of this list, and of course the answer is true. Right. Similarly, we can check for an empty list in a list of lists. So here we have 1, 2, 3, 5, and again we have the empty list in this nested list, and hence it returns true. Of course, there are more functions. Suppose we want to see if all the elements of a list are even, right? So one way is to go through each element of the list, keep track of a flag, and then return the flag, or use mem and other functions. So let's write this function. Let's try this function first. So we want to know if all the elements of a list are even, right? So that's the all is equal to, let me just type it for you first, list dot map function x mod 2 equal to 0 of this list 2, 4, 6, 8. If I run it, the result is true, but let's first understand how this function works, right? So when you see a large expression or a function like this, the first thing is to not panic and try to split the expression and understand how things work. So let's start from the basics, right? What do we have here? So we have, we know 2, 4, 6, 8. That's an integer list, that is fine. And what we are doing here is we are next calling list.map. We have to pass a function. And what does this function do? It takes an element of the list x and checks if it is divisible by 2. If it is divisible by 2, it returns true, right? So let me run this again. So we have a list, a bool list, where every element of 2, 4, 6, 8 returns true. So we have a bool list. Next, I want to check if there is any member of this bool list which is false. So I call list.mem of false. Okay. Is false in this list? No. Right. So it returns false. And then you finally negate it to say that every member in this list is actually even, right? It returns true, and we just assign it to all. So that's how you break a complex expression and evaluate it and test it out if you want to better understand the usage. Let's try this for the any function. Now that you actually understood this usage, this should be pretty trivial, because now you're just using list.mem. Is there a member in the list which is true? what is the list? The list that is returned by list.map. As a function, you check if it is divisible by 2, that is each element is divisible by 2, and you call 1, 2, 3, which says that any function, is there any element which is even, right? So if you run it, it will still return true because 2 is divisible by 2, right? So that's the all and any function. Of course, these are pretty long, and so the list module has a couple of useful functions called for all and exist. So you can simply do list dot for all function x mod 2 equal to 0 of 2, 4, 6, 8. Let's run this. That's true. And similarly, you can do list dot exist function x mod 2 equal to 0, 1, 2, 3. Again, this returns true. So the standard library has evolved into this present state with pieces of frequently used code which have been turned into useful functions, right? So it's a good way of having these helper functions as you build more code and modules and packages. Okay. Let's look at list search. So the find function returns the first element of a list, and that matches a given condition or predicate, right? Well, let's first see what is the type definition for list.find. So it takes a function and a list and returns the element of the list of type A which satisfies this condition, right? So for example, I can say list.find. So it's a function, and I'm giving the input list here. What is the predicate or condition I want to check? To return me all those elements, or the first element that is an even number, right? So let's clear the output and run it. So 2 is the first element that is divisible by 2, and hence it returns the result. Now if an element is not found, it throws an exception. So if we do x mod 2 equal to 0, and I give a list of only only odd numbers instead of even numbers. So this will basically throw exception not found, right? The filter function again is similar. It takes a predicate and tests it with every element in the list, but it returns the elements which match the predicate. So let's see the type definition, list.filter. So as you learn like new modules and packages, I would recommend actually going through the type definitions. So this takes a function and a list of type A and returns a list of type A. So what does function do? It evaluates for the type A, and if it matches the condition, it returns true, and that is part of the resultant list. So let's try an example here. We have list.filter x mod 2 again divisible by 2, 1, 2, 3, 4, 5. Let's run it again. So we have 2 and 4 which are even numbers and divisible by 2, and hence the results are shown in the output. There is also the partition function which can partition the input list into two lists based on a predicate. So in the following example, let's also check the type definition for list.partition. So it takes a function, a list, and returns a tuple of two lists, right, all of type A. So here we have list.partition. This takes a function, here again checking for the same condition, and we are going to split the odd numbers and even numbers into a tuple with two lists, one with even numbers and one with odd numbers. Let's run this, and we have a tuple int list with even and odd numbers. Okay. So the order of the input is actually preserved in the output in the case of filter and partition functions. All right, so I think you're almost reaching the 30-minute mark. Let's stop here, and then on Thursday we will resume and finish the rest of the list module. But do practice this documentation, try it on the OCaml.org play. Let me type that link as well to you. I will make this video also available on the YouTube channel so that you can review it and try to practice it. Let me stop the recording now. Are there any specific questions?